All right, so let's keep it going in section 4.2. So we've done our prime factorizations. The next thing, right, once we have everything broken down, is we're going to sort of take those breakdowns and we're going to use it to find GCFs. The first sort of question here, probably pretty obviously, is what the heck is a GCF? What is a GCF? I think I said at the very beginning of the last video, GCF stands for greatest common factor. GCF. And so this isn't greatest like it's the best, like it sort of did the best and deserves the most ice cream. This is greatest like largest. So this is the largest common factor. And then by common, we don't mean that it's shows up all the time. What we mean is the largest sort of shared, right, things that they have in common with each other. You guys know what words mean. This is probably not the kind of thing I need to get into too deeply. So it's the largest shared factor. So we're looking for, it's essentially the sort of overlap between two numbers. It's whatever kind of factors they have in common, whatever sort of factors they share. So to find this, what we're going to be sort of doing is find a GCF. Essentially doing two breakdowns, right? We'll sort of do factor trees for each of our numbers, and then we're essentially just going to look. I mean, it's not really any more fancy than just like, let's look and see what the numbers are that they both have in common. So, for example, let's find the GCF for, let's do, I don't know, 28 and, maybe something like 42. Sort of relatively random numbers. 28, this would be 4 times 7. We'll start by just doing our sort of breakdowns, right? So 28 would be 4 times 7. 7 is a prime. 4 is going to break down as 2 and 2. 42 is going to be 6 times 7. So we know at the very least, obviously there are 7s in common. And then 6 breaks down as 2 times 3. So the process here is pretty much just do those breakdowns and then look at the breakdowns and see what numbers overlap. It's a pretty sort of straightforward process, honestly. So we're just going to base this again, so not on the like interiors of the factor trees, but only on the ends of each branch. And so we're just going to look, right? So for 28, the first sort of end of the branch is 2. And what we're going to do is look at the other tree and see if we have a 2. In this case, we do. So what we're going to do, I like just doing sort of a little circle, and we're going to sort of build up our GCF. So in this case, right, we know that 2 is a shared value. They both have 2 as a prime factor. So, okay, if they both have it, then we're going to include it. It's a one-for-one connection, right? So even though there's sort of a second 2 here, we can't reuse this value again. So if we continue, right, sort of starting at the 28, we have another 2, but we don't have any more 2s with the 42. So this 2 is going to essentially go unmatched. It's going to go unused. The next factor here would be 7. We know we have a 7 over here in the 42, so that one we'll circle. We'll include that in our GCF. And then pretty much, right, we're out of numbers in 28. Honestly, that's enough for us to sort of say, well, then we can't match anymore, because if we run out of numbers in one of our numbers, we run out of factors. That's pretty much the end of story. Obviously, just to confirm, right, on the other number, we've got a 3. We don't have any 3s over here, so we've pretty much exhausted all of our options here. So the GCF is going to be sort of a 2 and a 7, and what we're going to do is just sort of remultiply them together. And so that would take us up to a GCF of 14, right? And so what that means is the biggest value, the biggest factor for these two numbers, that is the biggest number that we could divide into each of these, 28 and 42, would be 14. It helps to sort of build them up this way. You probably would sort of tell me pretty quickly that like they both have a 7. But obviously, right, we can go a little bit further in that. You might be able to sort of reason it out. Both of these are even numbers, so then they would be divisible by 2, and also they're divisible by 7. So sort of those two ideas combined together, divisible by 2 and divisible by 7, means you're also divisible by 2 times 7, which is 14. You kind of reason your way there, but there's not really any reason not to sort of just do these factor trees, right? I mean, it's not like they're taking lots and lots and lots of time, assuming you don't have some, 3-4 digit number that you're trying to sort of work with. This concept we could even sort of extend to 3 different numbers if we wanted to. Let's say we had something like find the GCF between 24 and, 30, and let's go up to something like 48, maybe. 24, 30, and 48. What we're going to do is the same thing we just did, break down all of these values, and then we're going to look for any overlap, and we're going to look for overlap across all 3 of these numbers. So to be a GCF, right, for 3 values, it means you have to have numbers that show up in all 3 things. So we'll break it down. 24, right, would be 4 times 6 among other different possibilities. 6 would be sort of 2 times 3. So 2 times 2 times 2 times 3. 30 is going to be, what, 5 times 6, right? 3 times 10. You could break it down a bunch of different ways. 6 we know is going to be sort of 2 times 3. We have this 5 here. 48, again, lots of different ways to break it down. I'm sort of just off the top of my head saying 4 times 12. 4 would be 2 times 2. 12 would be, right, sort of 2 times 6. And 6 is going to be 2 times 3. Obviously, sort of in this case, as the numbers get a little bit bigger, up to 48, for example, we have more numbers to work with, but we're kind of really limited, in this case, I guess, by the 30 more than anything else. I mean, 30 has the sort of fewest factors here. So that's really going to be our sort of limitation more than anything else. Let's build our GCF. It's not sort of better or worse to have a big or small one. It just sort of is what it is. So 24, the first factor would be 2. This is Wheel of Fortune or something, right? Do we have a 2 anywhere else? Can we find a 2 in the puzzle? And we do. So we're going to have a 2 here, and here, and here in the 48. All these guys are even. So in my GCF, I can include at least 1, 2. Let's see if we have anything else. 24 has plenty of 2s. There's a second 2 here. 30 does not have a second 2, so that means this 2 and this 2 are not going to have anybody to buddy with. I don't even really need to check the 48, because if I don't have it in the 30, it doesn't matter if I have it in the 48, because I need to have a number across all 3 of these values. So the only thing else I could maybe include here would be the 3. In this case, I can, right? So I've got 3 here. 3 goes into 30, and 3 is going to be a part of 48. So my GCF, in this case, right, would be 2 times 3, be 6. So the biggest value I could sort of divide into 24 and 30 and 48 would be 6. And that's going to be my GCF. So the next thing is going to be to sort of take those GCFs and sort of use them to try to reduce our fraction values to lowest terms. So we're about to step back into fraction land in a way of sort of general number land.